3 words, fix this code. For a developer, that sounds harmless. It is the kind of request people make to AI tools every day. A bug appears, a file breaks, a piece of software behaves strangely, and the fastest instinct is simple: ask the model to fix it. But according to the story now circulating around the AI industry, those 3 words became the center of a much larger question. When does an AI model become too powerful to remain publicly available, and who gets to decide? The issue began with a model being asked to repair code that contained security flaws. When the request was direct, review this code for security issues, the model refused. Its safety guardrails treated the request as sensitive. But when the wording changed to fix this code, the model complied. On the surface, that looks like a loophole. But underneath it is one of the hardest problems in AI safety. To fix a security flaw, a model first has to understand where the flaw is. It has to identify the vulnerability before it can generate the patch. So the same capability that helps a defender repair software can also help someone understand how that software might be attacked. That is the dual-use problem. The same knowledge can protect a system or expose it. That is not new. It exists in nuclear technology, biotechnology, cryptography, and many other fields where powerful tools can be used for both defensive and harmful purposes. AI changes the scale. A single model can put that capability in front of millions of users at once. It can help a security engineer move faster, but it can also lower the barrier for someone with less experience to understand where a weakness might be. That is why this issue matters now. The controversy is not simply that a jailbreak existed. It did. Every major frontier AI system has jailbreaks. Companies find them, patch them, and then face new ones. That is part of deploying advanced AI in the real world. What makes this case different is the response. If a model can be restricted because of a prompt as common as fix this code, then the entire industry has to ask a harder question. Could the same standard apply to every advanced coding model? Because if it can, then nearly every useful AI coding assistant is exposed to the same problem. Finding bugs, explaining them, writing patches, and generating tests are not minor features. They are some of the most valuable things AI can do for developers and cybersecurity teams. You cannot simply train a model to reject every request to fix code. If you do, you do not just limit attackers, you also weaken defenders. Security teams need tools that can inspect broken software, detect risky patterns, explain why they matter, and help repair them quickly. In many cases, the people hurt most by over-restricting these systems are not malicious actors. They are the engineers trying to protect real infrastructure. That is where this story stops being only about a jailbreak. It becomes a governance problem. Powerful AI models do need oversight. Systems that may assist with cyber operations, biological research, surveillance, or large-scale automation should not be deployed casually. The risks are real, and governments have a legitimate role in managing them. But serious governance needs clear standards. When does a jailbreak justify restricting a model? Who reviews the technical evidence? What less extreme options were considered first? Are the same rules applied to every company? And does the decision actually make people safer? Those questions matter because AI safety is not just about blocking dangerous outputs. It is also about creating the right incentives. If a company is punished for being transparent about the dangerous capabilities of its own systems, while less transparent competitors face fewer consequences, the industry learns the wrong lesson. Do not disclose too much. Do not be too cautious in public. Do not give regulators a reason to slow you down. That is not how safer AI gets built. The world needs AI companies to be honest about what their models can and cannot do. It needs responsible testing, independent review, public benchmarks, and clear escalation procedures. But if transparency becomes commercially or politically dangerous, companies may have an incentive to hide risk instead of exposing it, and hidden risk is much harder to govern. This case also shows that power in AI is no longer just about who has the best model. It is about government contracts, cloud infrastructure, defense relationships, investors, export controls, and competition between the largest technology companies in the world. When a regulatory action affects one company at a commercially sensitive moment, it is reasonable to look closely at the incentive structure around that decision. That does not mean assuming bad faith. It means recognizing that AI governance now sits at the intersection of national security, market power, and public trust. That intersection is becoming one of the most important battlegrounds in technology. The core question is not whether dangerous AI capabilities should be regulated. They should be. The real question is whether that regulation will be transparent, consistent, technically grounded, and proportional, or whether it will become a system that rewards silence and punishes the companies that disclose risk openly. A prompt like "fix this code" is not the whole story. It is the doorway into something much larger. In the age of frontier AI, who decides which tools are allowed to exist, which companies are trusted, and what kind of transparency is rewarded? If the lesson the AI industry learns is that caution gets punished and silence gets rewarded, that is not a foundation for safer AI, it is a foundation for the opposite.